Okay, kids, here we are. We're on page 3. I'm going to start with number 24 here. There are multiple ways, again, to solve these problems. One way, probably to solve this one here, is that you're immediately thinking squiggles. So some of you might use this squiggle, which would tell us how to actually calculate this entire length. So that would be 5 is to 10 as 10 is to the whole, and I can call that y here. So I don't know if that was your intention to start this problem. You can see that 10 is the geometric mean between 5 and that entire hypotenuse of the large right triangle. So cross multiplying here, we will see that we will get 5y equals 100. So we're getting a y value of 20. That's just one way to do the problem. You can see now that if we have a 20 here, then that is beneficial with the big right triangle that we started with, because we have a leg of 10, a hypotenuse now of 20, and another leg that we're looking for. Maybe you can see that these both have a 10 that go into them. So we could really think of this as possibly replacing this x with a variable a or something. You could have a squared plus 1 squared equals 2 squared. Again, by not thinking this is a 20, thinking it is a 2, thinking of this as a 1 because a 10 goes into each. And then carrying this out, you'll eventually see that the a value here is 4 minus 1, so that's going to be the square root of 3. And then you can multiply by 10. Sorry, I lost my pen there. There it is. So multiply by 10, and you can get yourself the 10 root 3 that is the value of x. Now, I'm not going to lie to you. I would really like you to see that whenever we have the leg being, so look at the big right triangle, one of the legs being 1/2 of the hypotenuse, wanting you to see that 1 to 2 ratio and noticing that that's actually a 30, 60, 90 triangle. So 10, 10 root 3, and 20. There's other ways to do this problem by calculating this height here and working through it, but that's one way to find the answer that's 10 root 3. 25 here is a pretty straight up application of the center squiggle. The center squiggle is one that helps us memorize the geometric mean for this height of the big right triangle. So x is to 6 as 6 is to 4. And when we cross multiply there, we get our answer of 9. Alright, over here, it's going to get a little bit more complicated when we start putting algebraic expressions and like binomials in there. So hopefully you are noticing this squiggle here. Could be one that helps you. So the proportion will be 1 is to x as x is to 6 minus x. Cross multiplying there, you're going to get x times x, which is x squared, and that's going to equal 6 minus x. And hopefully your instincts are starting to be that we get everything to one side. So x squared plus x minus 6 equals 0. And that's the best way for you to start thinking about solving these quadratics. So now I have to factor a trinomial. I don't have a GCF to take out, so I'm going to start looking at the guess and check method. And hopefully you can see with a leading coefficient of 1 here, we're going to have x plus, x minus, and the factors of 6 that actually work here, x plus 3 and x minus 2. So what that's going to do is tell us that we have two possible answers to this problem. X could be -3 or x could be 2. Now if we put a 2 up here, we see that it actually checks out. 1 is to 2 as 2 is to 4. Does check at 6 minus 2, being that 4 that I was referring to. But if you put a -3 in there, you can see that we cannot have a -3 right here. So what we're going to do is call that an excluded value of -3, and 2 is our only solution. Okay, center squiggle here for this one. So what we're going to do is we're going to say 15x is to 5x as 5x is to 2. Now, some of you might not do this, but I personally like to keep these numbers a little bit smaller if at all possible. So I'm not going to cancel the x's. You don't want to do that because you're canceling possible solutions, but I am going to reduce the 15 over 5 to 3 over 1. Now I'm not doing this across the equal sign, I'm doing it just within one fraction, so that's okay. Alright, so I know this is kind of confusing, but what I have right here is a 3 over 1. So when I cross multiply 3 times 2, I have a 6, and that equals 1x times 5x, which is 5x squared. Okay, so when we, oops, I am sorry, I did notice that I did something wrong there. 3 times 2 is not just 3 times 2, I have the 3x sitting right there. So I'm glad that happened, so you realize how careful you have to be with that. So when we have this, your temptation again is to divide by the x's, but we don't want to do that because you're dividing possible solutions out. So what we want to do is subtract 6x from both sides so that we can get that one side equal to 0. So 0 equals 5x squared minus 6x. And now again, this is factoring, but this time we do have a GCF. So 0 is equal to, my greatest common factor is just an x here, x times the quantity 5x minus 6. And then we can see our two possible answers here are going to be x equals 0, or the other one is going to be x equals 6/5. Now how are we getting the 6/5? You have to think about this being equal to 0. Add 6, divide by 5, you'll get your 6/5. Looking back at the problem, we can again quickly see that a 0 is going to be a rejected answer. So the only answer to this problem is 6 over 5. Okay, finally, moving along a little bit here, we're going to try a little bit more application types on this worksheet. You got a kite. So here we go. I'm going to draw to the best of my, whoa, sorry, this is hard to draw on here. That's okay. So we have a kite. Big thing you need to know about a kite before I even read this problem is that one diagonal perpendicular bisects the other. We also remember that these consecutive sides are congruent and these ones are congruent here as well. So the shorter diagonal of a kite is 16 centimeters long. The longer diagonal is 21 centimeters long and is split by the other diagonal into a ratio of 2 to 5. So I can see here that this is going to be 8 and this is going to be 8. My shorter diagonal here is going to be split into 2 equal parts, which is 8 and 8. And then honestly, for that long diagonal, I'm going to think about it kind of like this. I'm going to draw a little diagram here to kind of show you. It says it's in the ratio of 2 to 5. So one way to think about it is, all right, 2x and 5x. We can think of it like that, split into that ratio. And then what we know is the longer diagonal has to be 20 centimeters or 21 centimeters long. So quickly we can say that, sorry, this thing's a little finicky at times, 2x plus 5x, that's our total of this whole 7x here, has to be a length of 21. So 7x is equal to 21. That gives me an x value of 3. Well, if the x value is 3 in this little scenario, that means this has to be 6, and this here has to be 15. So I just found out that this is 15 here, and this is 6 right there. Now, I hope that really excites you because the perimeter of the kite is what we're looking for, and you can see here this is a family. It's all about this right angle in the middle here. You have 4 right triangles now. So we have a 6, 8, 10, which is the 3, 4, 5 family. 3, 4, 5 family to make that 10. And then, you guessed it, folks, 8, 15, 17 family. 8, 15, 17 family. So the perimeter of the kite we can see by adding the 10 plus 10 plus 17 plus 17. And that's where we're going to get this 54 centimeters for the perimeter. And then hopefully you remember that the area of a kite is equal to 1/2 diagonal 1 times diagonal 2. And diagonal 1 here was 16, diagonal 2 was 21, both in the problem. So if we take 1/2 16 times 21, we get our area of 168. And that would be centimeters and that's the area. All right, moving on to this last one on this page here. Give me a second to scroll down here. We have a side of an equilateral triangle. Here it is. Okay, so an equilateral triangle. One side is 7 feet. We want to find the perimeter and the area of the triangle. Now, I'm not going to lie to you. I really hope you can realize very quickly that the perimeter would be 21 feet because it's an equilateral triangle, 3 sides. All right, but to find the area, what we have to actually come up with is this height here. Okay, so if I'm going to draw down an altitude in an equilateral triangle, I hope that's pretty straightforward that we now have a special right triangle here. So looking here, I have a 90-degree angle. Opposite that is always a 2x in our scenarios. Remember, opposite the 30 is x, opposite the 60 is x root 3. So looking at this scenario, I need, maybe go to the major goal you understand is you got to do the area equals 1/2 base times height. Well, the base of the triangle, I hope you can recognize, is 7, but the height of the triangle is what I'm trying to find right here. Well, if 7 equals 2x, I guess I can go to decimals here. Actually, let's keep it as a simplified radical. These 2's cancel. Your x value is 3.5, or 7/2. So what that means is that height right there is the x value times root 3. So keeping it as a fraction, that's just 7/2 times root 3. And that's what's going to go in here. So putting that in there, by the way, 7/2 root 3 is the exact same thing as 7 root 3 over 2. So simplifying this, we can actually see here that this is really 7 over 1, remember, so the numerator is going to be 49 root 3. And then on the denominator, we're going to have 2 times 1 times 2, which is just 4, and that doesn't simplify. So that's actually the area of the equilateral triangle. And we can always find the area of an equilateral triangle if we only have a side given to us because of that 30, 60, 90 relationship. I hope you continue for more fun.